Okay, number 35 is an indirect proof. If you read right above it, they're actually having you look up at the figure that has A, B, C, D on it at the very top of page 102. I'll just kind of sketch it here in case it comes in handy. A, B, C, and D. And they said in this acetylene molecule, AB is equal to CD, so those two pieces are equal. B is between A and C. That's what that means. A dash B dash C just means B is between A and C. B dash C dash D just means C is between B and D. Use the facts to supply the reasons for the following direct proof that AC is equal to BD. So you already proved that in number 34. So you're going to take that as part of your assumption. Now, the reason I go over that is 35 is a continuation of 34, but I didn't assign 34. So we're supposed to use this additional fact that AC is greater than 2AB to supply the missing statements in this indirect proof. Well, our beginning assumption in an indirect proof is always the opposite of what is stated above. So we're going to try to show that B is not the midpoint of AC, but our assumption is going to be the opposite of that. So our assumption on the first missing statement is B is the midpoint of C, of AC, is the midpoint of AC. So that's the first missing statement there on number 35. If B is then you follow. If B is the midpoint of AC, then AB is equal to BC. Why? Well, that would be the definition of midpoint. The definition of midpoint is sums in midpoint. If B is the midpoint of AC, then AB would equal to BC. Okay? So they're going to go from there because AB plus BC is equal to AC. Okay, here's what they're doing. They're saying, because that's true, then 2AB equal AC. Okay, well, the reason what they did there is they just said, okay, well, AB and BC were equal, because that's what it means for B to be the midpoint. So I'm just going to take this BC out, and since it's equal to AB, I'm going to put it there. And if I add the two ABs up, I have 2AB equal AC. So that would just be substitution is the reason for that Y that you see on number 35. Okay, then it says, what does this statement contradict? Well, if you look back up, we know the things that we knew from before was that AC is equal to BD, and then we know that AB is equal to CD. If AC is equal to BD, okay, let me start over with that. What does this contradict? Well, we know that AC is greater than 2AB. That was the thing they told me up here. Here we're saying that 2AB is equal to AC. Both of those things can't be true at the same time. Therefore, this is a contradiction. This 2AB equal AC is a contradiction of this right here. And that's what they want to know. What did it contradict? It contradicted that. So we say, therefore, our assumption is false. Therefore, since we assumed B was the midpoint of C and our assumption was false, it follows indirectly that B is not the midpoint of AC. That's how an indirect proof works. And so that's how you would do number 35. Number 36 is another proof. And they're trying to prove that angle 1 is equal to angle APB over 2. And you're not going to have to figure out how to get there. You're just going to have to provide statements or things that are missing. They're giving you kind of a framework here. So number 1, it says PA, PC, PB. We're just establishing that these are segments, okay? And they said that's by hypothesis. The hypothesis, if we glue these correctly, PA, PC, PB, PC would bisect that angle P there. Let me just quickly draw some representation of it, though you should be looking in your book on page 102. This PC would create equal angles 1 and 2 is what they're saying. Here's PB, PC, PA, okay? And we didn't have to fill in anything there. We're just noticing it. Now, step 2 says angle 1 plus angle 2 would equal what? Well, what angle is that equal to? It's angle BPA or APB. I'll just put APB, okay? So the reason that's true is if you look, it's just the betweenness of rays theorems. If Between-this-array theorems say that if we add those together, we get the whole thing. It's kind of a weird way to say it, between-this-arrays, but that ray PC is between ray PA and PB, and that's what statement 1 was saying. Statement number 3, PB bisects APB, and that was by hypothesis. They told us that, so there's nothing to fill in there. I'm not even going to write it out because that will just take up more time. Statement 4 says angle 1 is equal to angle 2. And how I know it's that is it says the reason is if a line bisects an angle, it divides the angle into 2 equal angles. Up on step 3, they just told us PB bisects APB. Should be PC bisects APB. So if they're bisected, then these 2 little angles here are equal that are created, okay? And so that was what was missing there was this angle 2. So that's what was missing. Here's what was missing on the number 2. I'll try to circle what was missing in red in case you're having trouble following along. Number 5 says angle 1 plus angle 1 is equal to angle APB. Okay, there's 2 things going on here. Let's just look at this statement. Do you see that up here they said angle 1 plus angle 2 is APB? That's almost like this. And then here they said angle 1 is equal to angle 2. All they did was take this 2 out, and since 1 and 2 are equal, they stuck another 1 in there. So what reason is that? That is substitution. So you know you need substitution there. And then they put below it 2 times angle 1 equal angle APB. That's just adding them together. You could put addition here. I don't even know if the answer key says anything or not. So the part that we were writing were the reasons here. And again, if the answer key just says substitution, okay, that's fine. And then the 6th one says angle 1 is equal to APB divided by 2, which is, remember, this is up here what they wanted us to prove when we very first started out. How did you get from step 5 to step 6? How did it change? Here's angle 1, here's angle 1. It used to be 2 times angle 1. They got rid of the 2, so what they must have done is divide both sides by 2. That made the 2's cancel out, and it left me with angle 1, and then I have APB over 2. So that was just division. You could say division, or you could say multiply by a reciprocal, or whatever. I think the book says division. All you're doing is supplying these reasons here. They're telling you what to do, and they're just leaving out something every once in a while. That's all there is to 36. Start on number 15 and work as far as I can. 15 refers to a picture in the book on page 101. I'm not going to redraw the picture. It would take too long, and I'm trying to get this video made during lunch because there's been just so you have it in case you get home. So on page 101, it's referring to this origami duck here on figure. And so they have folded it, and then they unfolded it so you can look at the picture. So I'm looking at the 2 squares there, and on 15 it says, does point E appear to be the midpoint of AB? Well, if you look at the square they drew on the right, no, it doesn't look like it does to me. Maybe to you it does, but I don't think so. It looks like it's much further over. Is point E between points A and B? Well, yeah, it is, isn't it? I mean, we can tell that by looking at the figure. It is, A, and then you got little E is kind of here. Definitely between, okay? 17 says, because BAC, and you kind of need to trace that, BAC, it's like half the square. You can see it easier if you look at the left-hand square. Because BAC fits onto DAC, B and C are congruent. That's the definition of what congruent is that they fit on top of each other. Which angle is bisected if BAC equal DAC? Well, you could look at it a couple of different ways, I guess. You could say that angle DAB, that basically angle A is bisected, or you could look at it as angle C was bisected, and I could write that maybe as angle BCD. Both of those angles look like they're bisected. Just depends on which corner you want to look at, I guess. Okay. 18 says, name 3 more angles that are bisected in the folding process. Well, okay, so I named 2 here. They only asked for 1, so one of those could count as my 3. But if you look at the square on the right, it looks like angle ACD is bisected. Looks like there was a fold there that cut the half in half. And then if you look at the top half, it looks like angle ACE is bisected. because it looks like they took the top half and folded it in half. So all in all, you would have one of these two listed on 17, and you could keep one of those for your 18 answer and then list these other two. 19 says, angle BCD is a right angle because the process starts with a square, and squares have right angles. Find the number of degrees in each of the following angles. If you look at ACD on the left-hand side, it's easy to see that it's going to be half of a right angle. So what's 90 divided by 2? Oh, it's 45 degrees. Okay. 20 says angle FCD. Okay. If angle ACD, which let's say it's this angle right here, the angle FCD is where they came in and they cut that in half. So it would be 45 split in half. I would divide it by 2, and that's what 45 divided by 2 would be 22.5 degrees or 22.5 degrees. Okay. 21 says, what is FCE? Okay, so let me use a different color. I'll use red here. FCE would be this half and the other half. Well, now if you think about it, when we started out, they cut the whole square in two. So each of these little pieces here are going to be the same because they were halved and they were halved again. So each of those little pieces is 22.5 degrees. If they're asking me for FCE, that would be this one, this little piece, and this little piece. So two little pieces. So 2 times 22.5 would give me the 45 degrees back, wouldn't it? Okay, I'm going to try to fit in 23, 22 and following over here in this blue. What is DCE? DCE, let me use green just because I haven't used it, and maybe it'll stick out. DCE starts here and it goes here. How many of those little segments are there, angles are there? There's 1, 2, 3. So that would be 3 times 22.5. Or 45 plus 22.5 is what I'm going to do just because I can add that faster. 67.5 would be what that would be. I can just think about what's half of one of those halves and count up how many there are. And then that's it. DFC. Oh no, I somehow got off on my numbering. 16, 17, 18, 19, 20, 21. 22 was DCE. Oh, it's this, 22 is this. I took 2 lines to do that problem and labeled the second line the number, and it wasn't. What is DFC? Okay. In order to get DFC, let me use yellow to outline. DFC is this angle right here. Okay. It's part of a triangle, right? In this triangle, I know that all the angles in a triangle add up to 180. This is a right angle, so it's 90. I know this little piece is 22.5, so if I add up what I have so far, it's 112.5 degrees that I have. But if all the triangle is going to add up into 180 degrees, then this one up here that I'm trying to find, that I'm coloring in purple right now, that would be 180 minus 112.5. Okay, so if I do that, I'm just going to use calculator real quickly just because I don't have room to really write it out on the iPad. So 180 minus 112.5 would be 67.5. Okay, so that gets you through some of the harder problems on 3.4 if you're trying to work them and you're running behind.